Well, the next question was, if you're at a point x star, y star, which is within the sphere, then if you're inside the sphere, clearly the sphere, at least the upper part of the sphere, is above you. Because you're in the xy plane, you get a great circle in the xy plane, everything's symmetric with the xy plane. Clearly there's sphere above you if you're in the xy plane. Now I drew a pretty bad picture here. I didn't want to draw a really good one because I wanted you to think it through yourself. And also, you know, sometimes I just draw bad pictures. Could have been more careful in drawing this better though. Okay, but what I've represented is this blob here was originally supposed to be your rectangle, your delta x by delta y rectangle in the xy plane. And that rectangle is assumed to contain some point x star, y star. So the point x star, y star is inside of this rectangle, wherever it happens to be. And we want to know how far you have to go from the point x star, y star to get up to the circle. Okay? Again, insufficient understanding of the Pythagorean relationship really kind of got in the way here. There are many ways we can do this. The way I chose to do it is, okay, people are having trouble with this. Let's draw a vector from the origin to the point x star, y star. Okay, then that vector would be x star I plus y star j. Now people were a little fuzzy on that, but I think people understood that fairly well. So make sure you understand this. Okay? And now what we're going to do is we're going to make a vertical plane that goes through the origin and the point x star, y star. So that'll be a plane that I've kind of indicated lightly in yellow here. And I can actually at least trace the outlines of that plane a little more clearly. Now here's the line that goes through the origin and the point x star, y star. It's in the xy plane, since both the origin and the point are within the xy plane. So we're cutting the surface with this plane. We're cutting the sphere with this plane. Now it's cut down below as well, but we end up mainly focusing on the upper half of the sphere, because everything that happens in the lower half of the sphere is just a reflection of whatever happens in the upper half. So if we understand what happens in the upper half, we're going to easily understand what happens on the lower half. So here's a plane down to the xy plane that cuts this sphere. And any plane that cuts the sphere is going to cut it on a circle. And in this case, the circle, well, the plane goes through the origin, so the plane includes the origin. And the result of that is the circle is going to have the same radius as the sphere. So we indicate that over here. There's a picture of where the plane cuts the sphere. Okay, and I drew both the upper half and lower half of the resulting circle. Okay, we have the z-axis here, and incidentally a vertical plane through the origin and another point in the plane does contain the z-axis. Another way of describing this plane is it goes through x star, y star, and contains the z-axis. That would have been a sufficient description, and you want to think about that. Okay, now, so we have a z-axis here, and we have another axis that I've labeled with a question mark. We could come up with a label u or something like that, but that axis coincides with this line here. Now along that line we have our point x star, y star, and that point was inside the red rectangle, so maybe I should indicate that point as I have elsewhere by a red X. This is where the red X would be within this picture. If the red X is at the tip of this vector, if the red X is at the point x star, y star, there it is. Now my question is, how far along this axis is it? Okay, this axis makes an angle with the x and the y axes. How far from here to here? Well, the vector from here to here is x star I plus y star j. It has magnitude square root of x star squared plus y star squared. Or you can just say, well, from the origin, from 0, 0 to x star, y star, the distance is x star minus 0 squared plus y star minus 0 squared. Many ways you can visualize that. So this point on this axis would be a distance x star squared plus y star squared from the origin. Now the purple line here, and I have a double arrow on that line. It's a little hard to see the lower one because the X I just drew. But this double vertical arrow here represents the distance from the plane up to the sphere above the point x star, y star down in the xy plane. There's your distance. Okay, well, let's look at what we've got. We know this distance. If you're given the coordinates x star and y star, you know how far this is. How are you going to figure out how far this is? Well, you know how far this is. This is a radius of the circle. So we end up with this picture here where we've got a triangle, one side of which has length x star squared plus y star squared. Another, the unknown length that we're trying to find, and that length is going to be how far above our point we have to be in order to encounter the sphere, to be on the sphere. The distance from our x star y star point to the point directly above us on the sphere. And this side is the hypotenuse of this right triangle, has length 4. I'm going to call z max the distance. So what does the Pythagorean theorem tell you about z max? That's what we're trying to find. Well, it's very straightforward, but people mess this up. And you really don't want to mess this up. I'll tell you how it was messed up, but here's what you do. That's just this squared plus this squared has to equal this squared. So this squared plus this squared equals this squared. Square both, well, square this quantity, and you get x star squared plus y star squared. So now you have x star squared plus y star squared plus z max squared equals 16. And you solve it for z max, or in this case I solve for z max squared, so that z max would be plus or minus the square root of this expression, and that's very straightforward. People took the square root of this and got things like 4 minus the square root of x star squared plus y star squared. Square root doesn't distribute over addition, and certainly not over subtraction. Okay? Square root is not a linear operator. The square root of 25 is not 7, as it would be if you believed that, or if the square root was a linear operator. So, or if the square root distributed over addition. So you just don't want to make those mistakes. You know, if you're in this course, you're way beyond the point where you should be making these mistakes. Unfortunately, you've been in prerequisite courses in which too many people were incapable or unwilling, not really incapable, but unwilling to do the work to really learn the course, so you weren't required to do it either. And you didn't. So you're going to have to keep remediating these little things that you shouldn't be stumbling over at this point. Now you're smart enough to do that, so just be sure you do. Okay. So now we have an expression, be the square root of this, for how far we have to go to get there. So we get z max equals the square root of 16 minus x star squared minus y star squared. Now I used the positive because I said how far do we have to go up, and all I said was how far, not in what direction. So we would discard the negative solution. However, the negative solution is important because if we go up to the point where z equals square root of 16 minus x star squared minus y star squared, we get to a point on the sphere. If we displace in the negative direction by the same distance, we get another point on the sphere. And it's kind of important to know where this point is and where this point is, and to understand that you might want to find both points, especially if you want to answer a question that involves the whole sphere. Okay, the question as asked can be answered only using the top half of the sphere. Okay, so there's the answer to that question, which I would have expected people to be able to answer, maybe with just a little help, in 2 or 3 minutes instead of 30. And I observe we're taking a lot of class time to get through these things, but I can't just assert them and expect people to go home and fill in the blanks. People don't have time to do that, so we have to spend a lot of time on stuff that we shouldn't be having to spend a lot of time on. Still, this is important enough to have spent the time on it. You really need to understand this, and that's really what I'm trying to say. Okay, well, we go on to the next question in a minute.